Okay, I think we'll just move on. The next presentation is from Cory Henson from Bezirk. He is a senior research scientist at Bosch Research and Technology Center, and he leads the design and development of protocols and data for Bezirk. So take it away.
Okay, hopefully that's better. Yeah, so if you look at my name tag or read the bio, it says I work for Bosch, which is certainly true. But very recently, my colleagues and I, in a project we worked on, spun up a startup company called Bezirk. And at Bezirk, we focus on developing middleware and personalization technologies for the Internet of Things. Yeah. And I'm going to be talking today a bit about some of the interoperability issues we faced and our approaches to solving them. So first, just a brief mention about Bezirk. So if you look at the IoT landscape and pay attention to what's going on this week, you'll notice that a lot of the frameworks and applications that we're talking about are very cloud-centric, right? So you have a bunch of devices collecting information, sensors, appliances, mobile devices, and this data is sent to the cloud for processing and analysis. So at Bezirk, we're looking to develop something a little bit differently. We're looking at developing communications at the local level, peer-to-peer, using a pub-sub architecture. And we believe that this approach has some benefits for privacy and security. If you're interested in this topic, my colleague Joao will be speaking on this tomorrow, far more eloquently than I could, I'm sure. But as we develop this middleware technology, we're coming across these interoperability issues, right? And this is primarily because there's a wide range of devices of different types, services of different types, and all of these want to communicate effectively with one another. And with our pub-sub architecture, sorry, I keep looking at it. With our pub-sub architecture, we can solve some of the problems we come across, right? So the scalability, for example, when communicating between a distributed system, but it doesn't really solve the interoperability issue, right? Because we find that there's still a very tight coupling between the services on the network and the messages that the services must use to communicate with one another. Yeah. So to make this a bit more concrete, we're going to use an example for personalized lighting. Yeah. And this is an actual real example that we're playing around with at Bezirk currently. So we have our friendly user Bob. Yeah. And as Bob walks from like one room to another within his smart home, the lights can turn on and set to a particular color based on his preferences. So maybe Bob walks into the kitchen, the lights turn yellow. He walks into the living room, the lights might turn blue. Yeah, so fairly straightforward. So to implement this application requires 3 services. So first, on Bob's mobile phone, we have a presence service. So this is a service that tracks Bob's location as he moves from room to room. And we also have a profile service. And the profile service is responsible for learning and managing and distributing Bob's preference information. And then finally, on a home controller, we have the light service, which is actually responsible for turning on the lights and setting them to a particular color. Yeah. Okay. So now let's look a little bit more in depth about the communications between these services. Yeah. So when Bob walks into the kitchen, the presence service will detect this, will encode this information into a user presence observation, and will broadcast this to the network. Yeah? Our light service, of course, is listening for these types of messages, and this will trigger the light service to turn on the lights. But first, it needs to know what color to set the light. Right? So to access this information, it will query by broadcasting a user profile request. Yeah? And the profile service associated with Bob will receive this request and return back Bob's preferences. Now, to get these preferences, the profile service has to learn them, right? So we need some training data set. So when you walk over to the, the switch on the light over there and you turn it on, or you pull out your lighting app and you set the color to yellow, you're making a choice. You're choosing yellow over blue, right? And these choices can be observed, and they can be shared within the network, yeah? And it's these choice observations that the profile service would use to learn preference information, right? Okay. So we've seen, how these services communicate. But that's certainly not the end of the story, right? So if we consider presence services, right, so which track the user's location, there's multiple underlying technologies that can actually be used to implement this. So at Bezirk, we're developing a presence service that uses, Wi-Fi patterns to track a user's location. We could also see, you also see RFID being used for this purpose. If you have, if you want to track a user's location outdoors, GPS might be the way to go. And within, an open IoT network, perhaps you would see all of these working simultaneously. Yeah? And these different services are, implemented by different developers working for different organizations, encoding their data within different formats. Yeah? And so unfortunately what ends up happening is each of these will create their own observation data models and messaging. Yeah? So if we're writing a light service and we want to be able to interoperate with all of these different presence services, we need to write interpreters for each one. Yeah, and this is a real bottleneck for interoperability. It makes it real difficult to implement this light service. So I've been talking about the presence services, but the same story can be told for profile services. So again, at Bezirk, we're implementing such a profile service, but you can imagine multiple profile services working at the same time. So how do we go about solving this issue? Yeah? So what I would suggest is that we begin thinking about data as a first-class citizen, right? And let's, as cleanly as clearly as possible, separate the task from developing services from developing data models. Yeah? Now, this is not easy task. It's certainly non-trivial, right? So if we want all of these different presence services to share a model, then we need to do several things. So first, we have to make sure that this observation model is expressive enough that we can represent information from all these services. Yeah? But at the same time, we have to make sure it's simple enough that it can be picked up and used by developers without too much hassle, right? And striking this balance is not always easy. Yeah? But if we're successful at this, it certainly makes developing our light service quite a bit easier. Yeah? Now, some of you might be sitting here thinking that all this is quite obvious. Yeah? We've been working with this problem of interoperability and developing common standard data models on the web for quite some time. Yeah? And for that, I completely agree and say that perhaps this approach is bearing fruit, right? And to see this, we can look at schema.org. So schema.org is an ontology developed in collaboration between Microsoft, Google, Yahoo, and Yandex. And it's primarily used for annotating web pages, right? And it does this so that so that these major search engines can correctly interpret and index the information. So earlier this year, Google released a paper reporting that 31% of the web is now using this model. Yeah? So that's quite a lot of web pages. And they've seen 42% growth in adoption over the past year. Right? So this is quite successful, I believe. Yeah? And to me, this demonstrates that developers, organizations are willing to adhere to common standard data models if we can strike this balance between expressivity and simplicity. And I think schema.org does this very well. And so the question I'm asking now is that, as an IoT community, as we go forth and begin to develop data models ourselves, we should certainly look to the web for guidance and see what they've done. But I would actually go a bit further than that. And I would say that if we could reuse some of the data models that have been successful on the web, then this can certainly bootstrap our efforts, right? So if we go back and look at our personalized lighting example, we see that there was two primary types of information that were of particular importance, right? So we had observational data, representing presence observations, user choice observations. And we had user profile data, specifically representing preference information. And I think in this regard, the personalized lighting app actually serves as a pretty good prototype for IoT apps in general, right? Because there are many IoT apps that would benefit from the context awareness enabled by observational data. There's many IoT apps that would benefit from the personalization provided by user profile data. Yeah, so I think this is actually a good place to start. So first, let's look at modeling observations. Over the last couple of years, there's been, quite a lot of work in this area, modeling sensors, modeling observations for representing this data on the web. And a lot of this work has been spearheaded by two organizations. So the World Wide Web Consortium and the Open Geospatial Consortium. And last year, these two groups actually combined efforts for the first time, in my knowledge, to standardize something called the Semantic Sensor Network Ontology for representing this kind of information. So they consider it to be quite important. And if you spend any time with this ontology, or even just look at this example here, you see that it's quite complex. So this diagram is actually just a pretty small subset of the concepts and relations in this model. And this is actually the primary complaint we get from developers, is that it's just too complicated and hard to use. I mean, not many developers have a week or two or a month to look at this model and try to understand it. And the complexity perhaps is not so surprising. So this was developed originally by a group of geoscientists and logicians, looking at some pretty complicated use cases. So they were looking at environmental weather monitoring, climate science, or climate change, these types of things, right? And just for full disclosure, in a previous life, I was one of these. But now, working on IoT applications like our personalized lighting, what we really need is we need a minimal subset of this model that is specifically tailored for IoT applications. So what this means is, one, we need a lightweight model that is more applicable for peer-to-peer communications. And we need a model that's simple, right? It can be picked up and used by your average IoT developer working on IoT applications. So what do we mean by a simplified observation model? So I would say an observation is primarily composed of 4 parts, right? So first we have the thing being observed. We have the sensor that's observing the thing. We have the context in which the thing is observed. And this includes location, time. And then we have the data produced by the sensor. And we believe that this kind of strikes that nice balance, right? So it's expressive enough to handle a lot of different use cases, right? To be able to model multiple different types of observations, but yet it's simple enough that it can be picked up and understood fairly easily. And in our personalized lighting example, this is the model we're using. So we're using it for modeling not only user presence observations, but also the user choice observations. And the user choice observations actually serve as an interesting example here. So, the SSN model was developed, as I said, for environmental applications, right? So certainly there's no concept of a user or a person in this model. And there's definitely no concept of a user's choice. Yeah? But luckily, there is such a concept defined within schema.org. So perhaps this isn't so surprising. Schema.org is fairly comprehensive. I'm not sure if I mentioned this earlier, but they can model things like persons, organizations, places, events, choices, you know? And in typical schema.org fashion, it's pretty straightforward and simple. So there's three primary concepts here. So you have the agent, which is the user making the choice. You have a set of options the user can choose between, you know, so red light, green light, blue light. And then you actually have the choice the user made. Yeah? And this model is, you know, it was designed for representing user choices on the web. Yeah? But with, you know, a minor effort, we can integrate this with our observation model. Yeah? And, you know, within Bezirk, when we're looking at personalized applications, this model has actually been quite invaluable. We use it quite a lot. Yeah. And moving away from observations into user profile information, we could tell a very similar story. Right? So over the web, or over the last few years on the web, you know, there's been quite a few models for representing user information that have been successful. So I show three here. With friend of a friend, vCard, and more recently schema.org representation of a person. But unfortunately, these models are not able to represent context-sensitive information. Right? So, you know, our user Bob, who, you know, prefers the light to be yellow in the kitchen, but, you know, blue in the living room. This type of information cannot be represented by these existing models, right? And this kind of information is critical for IoT applications specifically. So to solve this challenge, we're looking at, or not just looking, we're using the user profile ontology. And this is a model that is specifically designed for annotating user information with the context in which that information is valid, right? So we can represent preferences that change between, you know, the morning and the afternoon, or that change between room to room. Yeah? And we can then extend this model with our favorite user profile model that's been successful on the web, right? So even if, you know, schema.org person is not context sensitive or cannot represent context sensitive information, when we combine it with the user profile ontology, all of a sudden we have this ability to represent this type of information. This is quite valuable and useful for us. So, just to wrap up, you know, we're seeing that, you know, due to the, you know, dynamic nature and the heterogeneity we see on the Internet of Things, interoperability is certainly a challenge. We've heard it several times today so far, at least I have. And so when we go forth and we start designing data models, you know, to mitigate this challenge, you know, we should certainly look to the web for guidance and for lessons learned. But I feel like we shouldn't reinvent the wheel here, right? And we could actually bootstrap our efforts if we begin to reuse and repurpose models that have found success on the web already. And I tried to show a few that you know, we believe that will be particularly applicable. So, you know, the SSN model for representing observational data, context information, the user profile ontology for representing context-sensitive user information for personalized applications particularly, and then schema.org for pretty much representing everything else. Yeah, so with that, thank you for your attention. If you have any questions?
Well, thank you. For those of you that heard this morning when I and my colleagues talked about giving data context, you saw that we went about it about the same way. So I'm really happy to see that we're not the only ones that are using semantic web technologies and semantics to give data context. And you even had the same vocabularies or ontologies. So afterwards, we'll be in a bar comparing turtle files. We have time for questions, if you have any. Yes?
There's a company that I know about called, I think it's called Satellus. Have you heard about it? They do fine-grained GPS that works inside of buildings.
Satellus?
Satellus, yeah.
I'm not very familiar,
Okay,
no.
you should
But
look
I
it
will
up.
look it up. Okay.
Okay, great.
Okay. I just wanted to note on the purpose of positioning that working in an oil company, we can't really bring devices out, so we have to come up with other things. So it has to work in multiple conditions. Any other questions from anyone? Yes.
So I see you have proposed a schema or like simplification of schema that's already there. Like who's driving to standardize, or like, I guess I see the value that you're bringing, but what's the next step here as to, you came up with something, I heard you have something similar. Is there like some consortium or group that is trying to say, all right, this is like-minded people, go do it?
Yes, that's a good question. I probably should have focused on that more. So if we're talking about observations, for example, this is probably the model I know a little bit more about. So we said several things were important, right? So we wanted a lightweight model for peer-to-peer communication, and we wanted a simplified model so the developers can use it. Yeah? So we've actually argued these for this quite successfully to the W3C. And in fact, these two are actually now requirements in the new upcoming standard. Yeah? The working group working on this standard says that it should be developed or released around the end of the year. I'm quite suspicious. I think it'll take longer than that. It always does. But yes, we are working with current standard organizations, pushing some of the ideas we have. Joao was actually in Canada recently during the World Wide Web conference, talking during the face-to-face meeting within the Web of Things interest group, which is also a W3C group, right? Talking about some of the technologies we're working on. So yes, I think working with standards and getting our ideas out there is certainly important.
As the standards come out and evolve, are we going to see a proliferation of little adapter services that convert, older legacy formats to what some of the newer standards are going to be? And are those going to, find their way into our IoT, services environments?
Yes, I mean, there's certainly certain organizations that are going to be slower to adapt, right? So nobody's going to change overnight. Hopefully, if the models, the more people use them, the more useful they become, and more organizations are pushed to adopt them themselves. And so yes, this would be the way to do it. Most organizations aren't going to completely rewrite their code base to work with the new standard, so you need some translation from what they used before to the new representation. So yes, writing translators seems the obvious way to do this.
Okay, I think that was a nice finishing question. It's now time for the next and final. Thank you very much. And it's now time for the final presentation for today. I haven't seen them here either, so there he is.